I will illustrate two problems as a sort of a short review of inductance in AC. Here we have a source of 120 volts AC at 60 Hertz and it's driving a circuit which is one resistor in series with one inductor. So the first thing we got to do is calculate inductive reactance XL. XL is equal to 2 times pi times frequencies times inductance. That equals 2 times pi times 60 hertz times zero point 0.8 henries, which equals 302 ohms. We draw a vector diagram where resistance is the reference, but that XL is leading resistance by 90 degrees. So now we need to do is calculate the impedance Z. We use the Pythagorean theorem and we can say that impedance Z is equal to the square root of 300 ohms squared plus 302 ohms squared, and that equals 426 ohms. We can find the phase angle by saying that tangent theta is equal to 202 ohms divided by 300 ohms, or that theta is the arctangent of 302 ohms divided by 300 ohms, that equals 45.2 degrees. We always have to find the total current in the circuit, but we have to take the phase angle into consideration. So we say that the total current is voltage divided by impedance. In this case, 120 volts at 0 degrees divided by 426 ohms at 45.2 degrees, and that equals 282 milliamps at negative 45.2 degrees. What we have done with this calculation is we have shown that in an inductive circuit, the current lags the voltage, in this case by negative 45.2 degrees. Let's look at a problem where we have a resistor and an inductor in parallel. And let's begin as before calculating inductive reactance XL, which equals 2 times pi times 60 hertz times zero point 0.8 henries, and that's 302 ohms. We calculate current number 1, which is current through the resistor, and that equals V divided by R, 120 volts divided by 300 ohms, which equals 400 milliamps. To calculate current number 2, which is current through the inductor, we have to say that it equals V divided by XL. In this case, 120 volts at 0 degrees divided by 302 ohms at 90 degrees, and that equals 420 milliamps at negative 90 degrees. And that's because we have to remember XL leads resistance by 90 degrees. We now draw a vector diagram where current number 1, which is through the resistor, is the reference at 400 milliamps. But that current number 2, which is current through the inductor, is 400 milliamps but at negative 90 degrees. We find the total current because it's the square root of 400 milliamps squared plus 400 milliamps squared, and that equals 567 milliamps. We still need to find the phase angle by saying that tangent theta is equal to 400 milliamps divided by 400 milliamps, or theta equals the arctangent of 400 milliamps divided by 400 milliamps, and that equals 45 degrees. So once again, we see that in an inductive circuit that the current is going to lag the voltage. In this case, it is by 45 degrees.